Structure of atoms. In this chapter, we discuss about the properties of fundamental particles, protons, electrons and neutrons, and the experiments lead to the different models of atoms. According to Dalton's atomic theory, atoms are indivisible particles, but later scientists invented three fundamental particles of atoms called the subatomic particles. These are protons, electrons and neutrons. First, the discovery of electrons. The discovery of electrons done by J.J. Thomson by his discharge tube experiment. Discovery of electrons. The discovery of electrons is done by J.J. Thomson. He did it by his discharge tube experiment. This is the discharge tube. It is a glass tube fitted with two electrodes at two ends. The air, the gas from the tube can be removed using a vacuum pump connected here, and the electrode connected to this negative terminal of the battery is the cathode, and the electrode connected to the positive terminal of the battery is the anode. An ammeter is connected here. When current is supplied, there is no deflection shown by ammeter. But as the pressure inside the tube decreased, and at a particular very low pressure, the ammeter shows deflection. That means there is some discharge from cathode to anode. That is, some particles from cathode may travel towards anode. To identify these particles, J.J. Thomson then used a perforated anode, that is, തുളകളുണ്ടാക്കിയ ദ്വാരങ്ങളുള്ള ആനോഡ് ഉപയോഗിച്ചു. അതിൻ്റെ ആനോഡിൻ്റെ പിൻവശത്ത് സം ഫ്ലൂറസൻ സബ്സ്റ്റൻസ് കോട്ടഡ്. ദറ്റ് ഈസ്, ഈ ആനോഡിൻ്റെ പുറകിലായിട്ട് കുറച്ച് ഫ്ലൂറസൻറ്റ് പദാർത്ഥങ്ങൾ, സിങ്ക് സൾഫൈഡ് പോലുള്ള ഫ്ലൂറസൻറ്റ് പദാർത്ഥങ്ങൾ പൂശുകയും ചെയ്തു. Then the experiment continues. He found that there is a glow at the fluorescent coating. That means some particles from cathode travel towards anode and strike this fluorescent coating. That is, these rays are coming from cathode. These rays are coming from cathode and travels in straight line if they are not deflected by an external magnetic or electric field. But an external electric field is supplied. This glow deviates to this positive side of the electric field. That means this cathode rays constitute of negatively charged particles called electron. The properties of cathode rays can be summarized as: they travel in straight line in absence of electric and magnetic field. They composed of negatively charged particles called electrons. The characteristics of cathode rays did not depend upon the nature of material by which the electrodes are made and did not depend upon the type of gas filled in the discharge tube. Cathode raysന്റെ സ്വഭാവങ്ങൾ എന്തൊക്കെയാണെന്ന് വെച്ചാൽ, ഈ കാഥോഡ് റേസ് മാഗ്നറ്റിക് ഫീൽഡും ഇലക്ട്രിക് ഫീൽഡും ഇല്ലെങ്കിൽ നേർരേഖയിലാണ് സഞ്ചരിക്കുക. ഈ കാഥോഡ് റേസിൽ നെഗറ്റീവ്ലി ചാർജ്ഡ് പാർട്ടിക്കിൾസ് ആണുള്ളത്. അതിൻ്റെ പേരാണ് ഇലക്ട്രോൺസ്. കാഥോഡ് റേസിൻ്റെ സ്വഭാവം ഏത് തരം മെറ്റീരിയൽ കൊണ്ടാണ് ഇലക്ട്രോഡുകൾ ഉണ്ടാക്കിയിരിക്കുന്നത് എന്നതിനെയോ ആ ഡിസ്ചാർജ് ട്യൂബിൽ നിറച്ചിരിക്കുന്ന ഗ്യാസ് ഏതാണ് എന്നതിനെയോ ആശ്രയിക്കുന്നില്ല. Later, J.J. Thomson do the same experiment with a modified discharge tube to find out the charge to mass ratio of electrons. For this, the cathode rays from cathode ejecting from a cathode propagate towards anode, and through this anode, cathode rays travel in straight line is made to fall on B, the spot B on a fluorescent screen in absence of electric and magnetic field. When a magnetic field, a north-south pole magnetic field is placed perpendicular to the direction of propagation of cathode rays, the cathode rays now fall at C, and by the presence of electric field only, the cathode rays fall at A. Now, J.J. Thomson gave both electric and magnetic field as the cathode rays to fall at the original position B. And from this measurement of electric and magnetic field supplied, he found out the charge to mass ratio of electrons. Later, the charge of electron is found out by Millikan's oil drop experiment. By his oil chamber, the oil droplets, using an atomizer, the oil droplets fall through this hole, and this oil droplet is ionized by X-ray, and this ionized oil droplet can seen through this telescope, and by giving some charge, negative charge at the bottom, Millikan made the falling oil drops to stabilize at a position, and by knowing the charge and the gravitational force exerted on this oil droplet, he calculates the charge of electron, and by J.J. Thomson, the charge to mass ratio is 1.75880 into 10 raised to 11 coulomb per kilogram, and by Millikan, the charge of electron is minus of 1.6 into 10 raised to minus 19 coulomb, and therefore the mass of electron can be calculated as the charge by charge per mass ratio is equal to 1.602176 into 10 raised to minus 19 coulomb divided by 1.758820 into 10 raised to 11 coulomb per kilogram. Thus, the mass of electron is found to be 9.1094 into 10 raised to minus 31 kilogram. Later, the proton is discovered by Rutherford by doing the discharge tube experiment using a modified discharge tube, and the anode rays are invented, and the anode rays are also called canal rays. The properties of canal rays are: mass of canal rays particles depend on the nature of gas inside the discharge tube. Some particles of canal rays carry multiple of positive charges. For example, if you fill the discharge tube with the sodium vapor, it will Na+, only one positive charge is there. But if you fill it with the barium vapors, it will carry Ba2+, 2+ charge, 2 positive charges. The behavior of these particles towards electric and magnetic field is just opposite to that of the cathode ray particles. The smallest and lightest positively charged particle is from hydrogen and is named as protons. ഹൈഡ്രജൻ ഗ്യാസ് നിറയ്ക്കുമ്പോഴാണ് ഏറ്റവും ചെറിയ പോസിറ്റീവ് ചാർജ് പാർട്ടിക്കിൾസ് കണ്ടെത്തിയത്, ആൻഡ് ദാറ്റ് H+ ion ഈസ് സിമിലർ ടു 1 proton. Later, neutron is discovered by Chadwick. Chadwick discovered these neutral particles called neutron by colliding alpha particles on thin sheet of beryllium. ബെറിലിയം ഷീറ്റിൻ്റെ മുകളിൽ ആൽഫ പാർട്ടിക്കിൾസിനെ ഇടിപ്പിച്ചിട്ടാണ് ന്യൂട്രൽ പാർട്ടിക്കിൾസ് ആയിട്ടുള്ള ന്യൂട്രോണിനെ കണ്ടെത്തിയത്. We can summarize the properties of fundamental particles as this table. The electrons, protons and neutrons, the symbols E, P and N. Absolute charge per coulomb ആണ് ഇവിടെ തന്നിരിക്കുന്നത്. And neutron have no charge. Relative charge 0 and electron charge -1 +1. Relative charge ആയിട്ടാണ് നമ്മൾ ഇവിടെ കാണിച്ചിരിക്കുന്നത് -1 and +1. And mass of proton and neutrons are almost same, 10 to the power of -27 range, but the mass of electron is negligibly small. And therefore the approximate mass in unified mass is 1 and 1 for neutron and proton, but for electron it is 0. Thank you.